Okay, I think we're right on time. I hope we can deal with music on the background too, so I hope you like it. Good morning and welcome. My name is Irina. I'm from Romania and I'm a software architect at Particular Software. We're doing a very cool tool named Service Bus that deals with messaging. I also blog from time to time, and recently I've been doing some things around gRPC and API. I'm very passionate about APIs, and in the API section, there's also gRPC. So I have to make a confession at the first time in the morning that I love monoliths. And as you think you already noticed, history tends to repeat itself. Now, the mainstream things around software architecture is called modular monoliths. We all were like hyped about microservices, nanoservices afterwards, and now we're bringing the monolith back. So basically, we take our microservices and we're trying to stitch them back together, but in a more granular way. So the deal with monoliths is that the life is easy for developers, but not so easy for the business owners. In terms of they're hard to scale, they can be scaled, but at a higher cost than a microservice, for example. And it's a bad user experience. For example, if you have parts of your system that are very used, let's say you have an online shop and it's Black Friday, if you have a monolith, you would have to scale the whole chunk. If you have microservices, you would have to scale only those parts that are needed. Maybe not the login module, but only the ordering management section, okay? So that's where I come from. But I really loved working with monoliths because back in the days when I started and the monoliths were the thing, the machines weren't that nice, so when we built an app, we could have got a coffee and we relaxed for a bit until the build was finished and so on. Pretty much all the architecture looked like this. I come from a .NET space, so I always did backend and frontend, full stack development. And I remember a time when web forms was a thing, then MVC. And we had frontend that was rendered from the server side. Okay, so architecture pretty much looked like this. And then we realized that it's better just to have front-end apps written in whatever JS and backends that have a database or several databases. After that, we realized that the future is distributed, and now our architecture is more backend for front-ends. Okay, so we have several APIs that have their own databases that maybe communicate with other backends. So we don't know exactly what's behind the scenes. So in bigger software systems, we might end having different technologies that need to get data from one another. And when you first start to have microservices, you're doing this, RESTful APIs. And I'm going to ask you, who here developed a REST API ever? OK, most of us, right? Who here ever respected all the 6 guidelines that Roy Fielding introduced? Hands up. I'm going to put my hands down. Never. So actually, what we're doing is serve JSON over HTTP, leveraging only those constraints that Roy Fielding talked about that we thought they're convenient to us, right? So REST is like a concept that described an API that responds with JSON or XML or byte streams. But pretty much that's it. We do not have that section that makes the response a finite state machine. Maybe we don't use different media types to serve different representations of resources. So what's wrong with REST? We all do that. We all implement APIs in form or another, whether we're calling them microservices, but we all have endpoints that serve data to some front ends or some other backend apps. So there's nothing wrong with REST itself, as we chose to implement it. But there are other technologies out there. And remote procedure calls are one of them. So what is an RPC as a general concept? RPC is here in the code. Basically, an RPC concept will make the system behave as is a distributed system behave as is a monolith. The look and feel for us as developers is like everything is self-contained as it were in monoliths. So if we look here, that's nothing very fancy. We create an order by passing in a request, and we try to process the order, and if the order is successful, we arrange the shipping for it. Neat, clean, understandable. How many network calls are behind the scenes? Approximate? 3, okay? If you really think about that. But if you're looking from the developer's perspective, like from coding, it's like pure calling methods. You're not calling endpoints to get data. You're not making requests. But you're calling different methods. So this was the RPC idea. We'll make the system that is distributed behave like it's a monolith. And this concept has been around since the 70s or so. So long time. So as you already said, is a network involved whenever we're calling a different method. So it has this call a method look and feel, and it's prone to errors. Because, well, the latency is never 0, although we code as it is 0. So network communication is transparent in these kind of things. But we're here to talk about gRPC, not RPC as a concept, right? So people thought that, what if we could make that distributed system behave like a monolith because life is easier for us? And when we code faster. So gRPC started in 2001. Then it has been open source in 2005. And then fast forwarding a few years, we got it in .NET around 2019. And I have to tell you that the tooling was not that good, to be just politically correct and not use other terms. The tooling basically wasn't there in 2019. And if you wanted to work with gRPC, well, you had to improvise or to accept that the technology is not yet stable. We got it in .NET then, but other technologies like Go had it before, and Node.js the same. So gRPC is contract-based. We will have to define a contract that exposes types and operations in a language that is neither C# nor Java nor nothing. It's called protocol buffers. So when we do gRPC in .NET, we will have no more code references. So we won't have the right-click, add code reference client library, or a library inside our solution or so. The only thing that it will be common between our projects is this file that we will create that define the operations that we exposed. By default, it uses HTTP2, which it makes it inherently faster. And it has an efficient protobuf serialization, which gives a smaller payload. And from this, more performance. It is available in many languages, which will allow us to communicate, for example, with a Node.js app that has access to our protocol buffers file that defines operations. And it does code generation out of the box, as I will show you. So who here ever worked with SOAP and seen a WSDL page? OK, awesome. Pretty much all of you. I can say, and maybe it's not correct, but this proto file pretty much, to me, looks like that WSDL file. By looking at it, you'll see what operations are exposed. So if we look at a traditional request in HTTP2 in a random API, we have a client that makes a request to a server with specific things in URL and header and so on. Now, in between, we have this protocol buffers file that we write. And in order to get something from the server that has hosted the gRPC service, we would have to use a channel. I'm going to pause a bit over this channel concept, because we have to look at protocol level. HTTP2 is this box. And inside it, we can open a virtual pipe that flows data back and forth from the server and the client. So inside a single HTTP connection, we will have several gRPC requests if needed, and of course, several gRPC responses. So this pipe is opened over a single TCP connection. Unlike traditional HTTP requests, that opens a new connection for response, for a new request, for a new request. This will keep the connection open and will travel that data back and forth. So Short reminder what an HTTP request contains. So we have headers where we can add accept the MIME types that client wants and understand, and a lot of things that are specific to our business. Then we have the request body that can also be empty, and we have an HTTP method that tells the server what we want to say. It's like we're sending data, we're getting, we're updating, and so on. If we look at gRPC, we would have several bits that travel inside that request body through a channel. So we can have inside the body several gRPC requests. So from gRPC perspective, we're looking at this specific small bits that travel back and forth. So this gRPC request, if we look at it, it's split into two sections. We have metadata and headers specific to the small bit and the actual message, the thing that we're sending to the server to get data or to send data. OK, now we have gRPC requests that have these metadata or request headers, but we also have the ones that sit at the protocol ones. So it's the same thing. It's still HTTP2. We'll still have headers. And on the response part, we will still have what we used to have. Those are not going anywhere. But we still get some other things specific to gRPC. So an HTTP response traditionally has headers, body, and a status code that tells us what the deal is with our initial request. Well, when we add gRPC on top of it, we would get responses, gRPC responses. And these responses can be small bits traveling in response to those small bits initially. OK, so what happens here is that with the gRPC response, we have data that we expect as response. And at the end of all gRPC responses passing, we would get something that mimics response headers. It's a key value pair that gets sent only at the end. It's called trailers. Key value pair strings that we can add. And you'll see a lot of code too. So when all the responses have finished to be sent, we get the status code traditionally. It's 200 OK, it's a 404, or whatever. Usually it is a 200 OK because each gRPC response will have its own status code that is specific to gRPC. It's like, if you want, it's like adding an extra layer under the HTTP protocol. That is gRPC. OK? OK, so now with this out of our way, let's look at the proto file. That's the language that specifies what things we have exposed to our service. So first, we have to specify which is the syntax that we use. Usually, it's protocol buffers and a version. Protocol buffers 3 is the current one. And then we specify that for C#, we want it to be generated as namespace my first gRPC. So the code that will be generated by the protocol buffers compiler would have this C# namespace. If we want to generate this code for Java, we would have Java underscore namespace and with the package name. OK, so this is how we specify language-independent things. Then we specify which services and which operations we have. In our case, we have the service definition that is called Fibo from Fibonacci. And then we have compute Fibonacci, an input, and a return output. And the method is of type RPC. So basically, when we want to use these operations, we have to specify them here. And as soon as we start to distribute this file, all those consumers will look in this file and will see what is available. Here's the similarity with that WSDL page that we used to have in SOAP. You look there, you had operations, you had parameters defined, and so on. Now inside here, you'll see some messages. The keyword message and the name, and then some properties defined. The idea behind these messages is that once we compile the file, we will get C# classes if we compile it for C#. So after we compile this protocol buffers file, we would get a requested number class that we will be able to use inside our code. The same happens with Fibonacci result. We will have a C# class named Fibonacci result with a property called result. One thing that I want to note here is that we have int32 number, int32 result equal 1. Well, that is not an assignment. Okay, that's the order in the byte string, because we're talking bytes. So when we add more fields, those will be 2, 3, or we can skip some numbers if we want to deprecate fields, and this is how it works. Okay, not an assignment, just an ordering. The power of gRPC also resides in fact that it has 4 modes, or some people call them types, of transporting data over those small bits, gRPC requests. The first one is gRPC unary, which is one-to-one correspondence to our request response. We would have the client that opens up a channel and sends a gRPC request. The server will see that request, and it will respond with a gRPC response. How we write such a method is simply by annotating RPC, give it the name, give it the input, and so on. The second bit is server streaming, where the client sends a gRPC request, but it might get back several chunks, several gRPC responses in return. That happens, and I want to emphasize this, that happens over a single TCP connection. Every bit, every gRPC response is inside one single TCP connection at the protocol level. Okay? How we write such a thing is by adding the stream keyword to the part that it's supposed to be many of. So we get a request number type in, and we get many Fibonacci results back, because that's the stream. The third one is the opposite, where the client sends several chunks of data, several gRPC requests, and it will get back only one thing. Several ins, only one out. How do we write such a thing? By adding the stream keyword to the part that it's supposed to be many. So we'll have many inputs and one output. So it's many to one. The last one is combining the previous two, where the client sends several gRPC requests, and it will get back several gRPC responses. And after all the responses have been sent, it will get the trailers back, those key value pairs. How do we write such a thing? Just by adding the stream keyword to the both sides. Okay, so now let's see some code before we talk something else. How do we create such a project? I'm going to just open Visual Studio. It's a template. If you never worked with gRPC, you just click Create New Project. And then you find there ASP.NET Core gRPC. And you'd find the project, the template that is already there. You select it. Next, give it a name. Long-time support, because this is what we're currently using. And you will see that the project that is very funky. It's created. It has a few things that we already know. And I hope Visual Studio doesn't misbehave and gives me the code here. So you'll see that we still have appsetting.json, program CS, but unlike our traditional endpoints that we create, we have no controllers. So the controllers is not a concept in gRPC. What we do have is a folder called protos that's supposed to keep all those files that we write in that specific syntax, and the services folder that contain the business logic that back that contract. So let's examine those a bit. Grid.proto, it's exactly similar to what I showed you. So specify the syntax, specify the namespace, and then you start specifying what you expose. Say hello, gets a hello request, returns a hello reply, and so on. The idea is that you cannot have here methods that have no parameters. You have to have something, even though that something might be a message that has a name but no properties. This is how it's built, so we have to respect that. To accommodate this and prevent us from rewriting and reinventing the wheel, Google exposed something that is called Google well-known types that gives that type empty that is transformed to void-ish in .NET. So once we have this file on build, you'll notice that some code is generated for us. And that code, if you want to explore it, lives under object, debug, version.NET, protos, some here hidden. So you see that is grid CS and grid gRPC C#. That's the code generated for us. It's not rocket science. You could use that and do that by hand by running the CLI for the protocol buffers compiler, and you'd get a similar thing. So Visual Studio basically wraps up the CLI for protocol buffers. So if we open this, you'll see funky code that has a super nice warning: do not edit, because well, things might happen. And then you'll notice here that there is a static partial class called grid reflections, some funky code here that you don't want to see in depth. But what it's important for us is that it generates our types. You'll see that is a public CL partial class hello request. And if we look down here somewhere, we'll also see the other one. Okay, so now we'll be able to use those types in our code to provide business logic. So I'm going to hide this. And inside the services, I'm going to open greeter service. I hope this is visible to the back row. So we'd see that we have the greeter service. This is the name that you give the template has, so it can be anything. It will have a constructor, so you can inject anything from your IOC container if you want. Loggers, repositories, database context, whatever. It's a simple class that you can write. But the deal with this is that it extends the base class. This is greeter base that is auto-generated on compile time. So how do we provide business logic to what we have there? To this class named say hello that has this type and returns this type. It's by simply, I'm going to just copy this, by writing public override, and you're going to be prompted what are your options. And one of the only options that we get is this say hello request that is defined in the protocol buffers file. So we have to provide business logic for it. So I'm going to undo this a bit, just to show you that this say hello has the type that we specified, but it also gets an additional parameter that is there for us to access information at the protocol level. It's similar to what we used in Web API or MVC, HTTP context. We have access to the HTTP context from here too. We can get things like, for example, how is it called? Context, dot, and we can get things like the deadline of the current request, method, host, some request headers that sit at the protocol level, user state. There's also HTTP context. If we do this, get HTTP context, it will get what we already know. And from there, we can access request headers, HTTP-wise, the users, things about the connections, anything. Session informations, and we can get the user claims. We can identify a lot of things around the user. So anything we already know from Web API, it's still here. We just add some more things. OK. Some other thing that we have to look at is this. It's simply a middleware called gRPC that we have to use in any project that we would create. And then we have to tell it which is the gRPC service that gives an implementation for some things. Now, this is the basic. So basically, this is everything that we could look at in a random template. One thing that I also want to show you is that if we edit the project file, we'll notice here something. It's an item group called whatever. It has a node named protobuf that has a path to that file that we created or we got with the template. And also, this has a node that tells this is acting as a server. For a client, we would have had a similar thing, but instead of server, it would be client here. So this is helping. OK, with this out of our way, I'm going to run this. And apparently, Postman died overnight. It's supposed to be opened. So the easiest way of testing a gRPC service is to use some tool. Now Postman has everything implemented, and it's easier for us to look at it. So you can click New, and you would select here gRPC request. And from there, you'll notice that it's a similar experience to HTTP calls. you would have to enter the URL, and then you would have to select a method. But there is a catch. In order to find what methods are exposed in that gRPC service, you would have to point it to the gRPC protocol file. So since I don't know where that is saved, I'm going to right-click here, open containing folder, and I'm going to shamelessly copy the path. And I'm going to click here, import the proto file, point to it, open, and I'm going to select it. Okay, I click open, and you'll see that it kind of loads the method. And in here, it now discovers one method that we can call. We call it, and we say invoke. And you'll notice that now we don't get status code as 404, stuff like that. We get 1, 0 through 15, because those are status codes specific to gRPC requests. So this is canceled. Let's see, this is one, disable TLS, let's see. Fingers crossed, yeah. So now it's 0 OK. It's not 200 OK, it's 0 OK, which is OK in terms of gRPC. You'll see a message name, a message tab, and you can say use example message, and it will generate, based on that protocol buffer file, like a example request, name, Copenhagen. I should get that back. So click invoke, hello, Copenhagen. Yeah, so it's an experience that is similar to what we are used to in Web API. But this experience is now. 2 years ago, we didn't get that. So it's way better than it used to be. OK. Let's see what happens here. Not too many things, but I'm going to show you some other things. OK. I have a wider demo to show you. You'll notice here that I have, you'll also have access to the source code if you are to run it by yourself, so don't worry about it. On the server bit, we have this grid proto where I defined those 4 types of methods. This is the UNORI, server streaming, client streaming, and bi-directional. So I provided an implementation for all of this just to show you how it looks like. And I also defined 2 types, a request, just to mimic the request from HTTP, and a response, just to call it like that, from HTTP. So server has to be running if you want to call that. It's like in Web API. The temporal coupling is still there, so you have to have systems up in order to make them talk to each other. And if we want to give implementation for this, you will simply look in your service, hide yourself. OK, so you'll see here, say hello has an implementation very, very simple. It gets that type in, and then we return something as a response. Hello back with whatever I initially sent. And I also access the context to get the server IP and protocol. OK, what we have here, the second one, server stream. The same request, but I do a for loop that goes to this value and writes to the response stream async a new type of message. So we would have several gRPC responses in return to only one request. We will test those soon enough. Client streaming, now it has an async stream of type request, so it's many in. And it has a similar thing, so it simply looks in the request stream, and as long as it has things to read from, it will write those to the console. So it is the easiest logic that I could find just to mimic that a lot of data travels back and forth. So one response back at the end. The bidirectional one, it has a request in and a server stream of responses back. So many ins, many outs. This is what is generated. The code here it's similar. So while we have things to read from in the request stream, we will read them and write them back in the response stream. So we get them, we write them back. OK, so let's run these. I have some console apps. Here I will have a server instance that runs and listens for me to do requests. and you'll see that is listening on port 5000, waits for me to do stuff. The first thing that I'm going to try is the unary one to show you how it looks. And since we talked about the server and the server implementation, let's look at the client. The client is a simple console app that has some packages installed in here. gRPC Net Client is one of them, and gRPC Net Client Factory. So if we look in program, things are not very clean here, but it's easy to understand. So we create a channel. We specify where is the server living, so listening at this port. And then we create a client. It's similar to what we use when we call web APIs. We have an HTTP client that we create, we instantiate, or we use an HTTP factory for it. Now we obtain the greeter client that was generated for us. So I did no funky thing. That was there generated for me just because we had access to that protocol buffer file. And then we simply instantiate a new request type, and then we simply call the client, pass in that request, and that's it. We wait for a response, and then we write the response in the console. Yeah, so create the channel, tell it where the server lives, obtain the client, and then do a regular request. Remember that I told you that we have no more code references? So now, from the client's perspective, if I want to call the server, I would have to point to it some way or to use the HTTP client. But now look what I did. If we look in packages, frameworks, analyzers, there is not a thing that points to my server implementation that is here up there. The only thing that is in common is this grid proto, which has the exact same things as our server one in here. And it has the exact same thing because it is the same thing. Okay? How do we obtain that? Is by simply clicking dependencies, and we have, they changed the look and feel of this. Not build dependencies, where are you? So you'll get, if you're using Rider, for example, you'd have to edit the project file and to include this item group manually. You'll have to point where the protocol buffer file lives. So in our case, lives under the server solution, and I'm pointing to that. And it has this small bit here that gives us this funny-looking folder field that has a small arrow. So this is not an actual folder. It just points to that is on the server level. Where are you? Dependencies. Add. They put it under a hidden menu. So it add connected service. It used to be top level. Connected service, and from there you'll get this bit, service references. And if you click plus, it will prompt you to select what you want to add as a service reference. You can go back to the old WCF if you're missing it, and you can select gRPC. And here you click next. You browse and find the file that lives under the server project, protos. Click open, and then you specify what type of class you want to generate. So you can be a client, you can also be a server, or you want messages only. So only those types that we specified with messages keyword. So we'd say that we're clients, we click finish, and this behaves very nicely and installs all the packages that we need for us without us, oh, I have to install that and that and that. So it does it automatically. We click close, and then we would get this funny looking folder reference in here. So you see what this uses. So now when we go back to our console, server is still listening. And inside the unary bit, I'm going to do .NET run. And say hello NDC, and we get hello back with hello NDC value from localhost 5000. Okay, let's see on this server bit what happened. So we got a request finished that was made on HTTP 2 it was a post type request because everything gRPC is post. We cannot have put, get, or anything in between. It's post, it's sending data. And it pointed out to this specific method is localhost blah 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 greeter say hello. That's the name of the actual method that we're calling. Back we got 200 OK status code at the HTTP level, so on top of it, and it's of type application gRPC. That's the MIP type that travels back and forth. So we did an HTTP post, and on the calling party we simply get the response back. So 1-to-1 is super easy. The next bit on client streaming, let's say, it's similar. I point to the same protocol file. And by looking in the program, we will see that we create a channel pointing to the server location. We create a client that we obtain because it was generated for us. And then we loop and write async in the request stream for a specific amount of time. So we create as many request gRPCs, passing the index in there as a string. So we loop it through it, and we simply call it. So let's see how that looks. Client streaming. I'm going to clean this up. I'm going to maximize a bit. Make sure the server is listening. So .NET run client streaming. You see a lot of things moving on the server side. So it gets a lot of things. It gets requests with the content value of the I that we send in a loop. Many, many, many things in. And what happened? Here. And it said I got 90, this value as being the last index value in that loop. So it's one response to the client side from the server. The server streaming, it works pretty much in reverse. It sends server streaming program in here. We do a similar thing. I'm going to try to zoom in a bit. We obtain a channel. We pass it in to the client. And then we simply call the server with the server stream method, passing in a new request without anything. And then we will await for whatever the server is sending, as long as the server has something to send. So the question is, how do we know that the server finished sending gRPC responses? Well, it sends those trailers at the end, and this is how HTTP2 works. It sends at the end those trailers, and this is how the client knows, OK, you're done. I can move on. So I'll do the same on the server streaming in here. So from the right-hand side, we were supposed to send one thing, but we get many things back. .NET run, we wait a bit. See a lot of hellos coming back in here. And also, it writes back that it finds some trailers value that I also added just to show you how the trailers work. When all the responses are sent, these trailers come to finish the job. And on the server side, you'll notice that HTTP2 posts every single time 200 OK, application gRPC, but we call the server stream bit. Similar thing happens in the bi-directional one. Server still listens, but this time I minimized the loops. So we are sending 10 I's, and we receive 10 I's in the exact same order that we received them. Easy peasy, let's say. OK. This is all about the basics, but gRPC is not only about that. gRPC is supposed to do a lot of things very well already in the package. So it's by default, we have some internal gRPC that happen, and we need to be aware of. So status codes, as I did a preview, are not the same. We still have HTTP ones, but we also get some other ones, 15 of them, which is an enum that depicts the status code. Another thing, everything gRPC related that is bad, that you can use in order to validate, let's say, a gRPC request that comes, fields, and so on. How can you do the validation? By throwing exceptions. What kind of exceptions? RPC ones. There's only one type of exception that has whatever you add in it with the status codes that you add. that shows that something is bad happening in the gRPC initial request. What you can add interceptors, which are gRPC level. These interceptors are similar to our middlewares, but they run right when you want them per gRPC. For example, if you want to log something right before a gRPC request is made, you can do that. If you want to log something after the gRPC request, you can add that. So you have 4 entry points per each gRPC request, respectively, response. So an interceptor will allow us to interact with incoming or outgoing requests, can offer us a way to enrich the calls, like to add things in the headers and so on. Request headers. Protocol ones will stay there, but we'll get some other ones. Key value pairs in the request, key value pairs in the response, and response trailers also. So let's have a look. We'll look here in the client. Just a second. OK. Told you that anything is RPC exception. Well, a way to see what happened is to simply filter using the pattern matching, status code, the enum. And if I click here, I'm going to show you that we have aborted, already exists, cancelled, data loss, and some others. This is the enum that I told you about. Out of range, unauthenticated, unavailable, and so on. I'm going to undo this. I'm going to try to redo the cancel. OK, let's modify something. When we do the request, we can pass in some things. For example, on the server side, client streaming. Sorry, in here. Server streaming, context. Showed you already the context. We can add headers, and this is how you can add headers. We have context, request headers. We access those. And the similar way, we add the trailers. We do context, response trailers, and we add this key that is usable both on the request and on the response, named metadata entry, which are key value pairs. You just add them in there and pass it with the response. OK. Let's see here on the where are you? Server streaming. OK, in here. So one of the things that you can do with gRPC is to pass that a deadline, saying that I'm doing this request, but if I do not get an answer back in this amount of time, kill it, abort it. OK, so you can pass this deadline. And I'm going to say that this is uncommentable, and this I have to comment. OK, so now I'm going to do a server streaming, pass in a request, but I'm going to say, hey, in 1 millisecond, that's your deadline. And the server, when it receives that, if it's not capable of responding in that time, it will know that it doesn't even have to bother to create a response because it's aborted. So this is server streaming. This listens. This goes to the server streaming. And I'm going to do it again. Let's clean it. I just modified it so it will rebuild it. And you'd get now that your greetings timed out, just because we added that deadline here of 1 millisecond. So you catch this exception when you run the project. So console, your greetings timeout, because deadline exceeded. And you have ways of tweaking what happened inside here. OK, this is one thing. Another thing that you could do with gRPC is to tweak things in regards to maximum message size that should be for gRPC, response compression level. You can specify algorithms. You can specify maximum send message, maximum receive message, so you don't have to allow gigabytes traveling. If you have a lot of data that's big, it's not fit for gRPC. gRPC should be small enough to be easy to serialize, to byte arrays, and so on. So if you have huge chunks, maybe you should look to other technologies out there, not necessarily gRPC. When we talk about security, Basically, anything that is supported inside your APIs is supported here, because it still has HTTP2. So more than that, we can have two types of security-related information traveling with the requests. We can pass it at the channel level, which means it's a higher level, or individual per gRPC request. Well, you can add both if you want, or you can add only one of them. But you have two places where you can put them. What is supported? Azure AD anything but Kerberos and TLM on Windows, because HTTP2 doesn't know how to talk with Windows. So if you have Windows authentication, gRPC won't be a good fit for you. Okay, but anything can travel. The explanation to this is that anything that can travel it as an authentication detail in the request, in the regular HTTP request, can be here too. Okay, so some other things that gRPC should do awesome out of the box. One of them is client-side load balancing, which means that we can specify some resolvers in which our server instances can respond. So we can specify resolvers by DNS, or if we know the IPs, we can specify a static resolver factory. So let's look at these. We have the server instance running. I'm going to start another instance that will listen on a different port, 5002. And now I'm going to close them out of these things. I have another project that does a request. And you'll notice here that we get localhost 5000. And if I stop it and run it again, we get the response from a different server, the second instance that I started. This is done out of the box without us installing additional tools. It has a policy that we can configure in here. So it's another project, extra gRPC, in which we had client-side load balancing. So we specify a resolver factory. We specify the addresses where we know our server will live. Well, I hard-coded this, but in production environment, you should read this from somewhere. That will give you the flexibility of adding extra additional instances. For example, if you're running pods in Kubernetes, those will be automatically discovered. We configured, because we're in a console context, we have to configure this service collection bit. We pass in the resolver factory as a singleton, and then we do our usual thing. For example, we create the channel, we're passing in a name, and then we can pass gRPC channel options. In here, we can also specify credentials, like point to certificates or different things. And in the service configs, we can specify the load balancing algorithm that we want to use. Then we wrap everything together, and we're able to do the call. This plumbing is, let's say, very tedious, because I'm in a console. But when you call gRPC from a web API or some other context, you won't have to do all these things, because you will have everything in program CS wired up. OK, we build the service, and then we can easily call our, by passing in the channel with all the gazillion options, we get the response back. OK, so this is all that you can do in order to do client-side load balancing. So round robin or pick first, but pick first, it doesn't make any sense now, because it will always pick the first server instance that is available. So as soon as we keep playing around with this, we might get different server versions. So .NET Run, I shouldn't rebuild this. So we randomly get one or the other, or stuff like that. Client-side load balancing, a very cool thing. Another thing that this should do automatically without using additional packages, it's built in, is transient fault handling. We specify how it should retry and what kind of status codes it should retry, and it does it out of the box. So I'm going to comment this out. Because I don't want you to see me mistype things. So you can configure retry policies, and I added here the hedging policy too, because if you want to try it at home, you just have to uncomment it. So in terms of transient fault handling, you can have two types of policies: retries and hedging policies. The difference between these two is how the retries are made. Hedging, it does a burst of requests, how you specify them at once. And in case one of the requests comes back with a successful response, it will cancel all but the other ones. Retry instead does one by one, does a request, checks the status. Then if that's not OK, does another request. Okay, so this is the difference between hedging that comes from finance, they borrowed the term from there, and the retry policies that you all might be familiar with. In terms of what you can configure, we can have maximum attempts, which is the number of attempts that we can have for this, an initial backoff, maximum backoff, backoff multiplier, and here is the power. We can say which are the retriable status codes. We're thinking gRPC, right? So if status code for gRPC is unavailable or the status code internal, I want only those to be retried. Anything besides this, I don't care. Okay? So as soon as you pass in the retry policy, let's see if this is what options. Channel with retry, passing in the options. OK, everything is wired correctly. I also have to do some other thing, somewhere here. I try to mimic that something bad happens. And I'm doing this by looking at the request headers. It's a funny thing that I did, but I'm going to explain it to you. So I'm looking in the request headers, and I'm trying to search for a key that is called gRPC previous RPC attempts. This is the header that is audited by the platform to identify if the current request is a retried one or is the fresh initial one. So what I do if this key is not there when I first do the request, I'm going to throw an RPC exception with this status code of internal, and I'm going to add a random message. Not here, sorry, try again. But that's only the first time, OK? So I'm going to stop the server instance. Say hello is the unary one. Console, I'm going to stop this. I'm going to stop this too. I'm going to call it .NET Run. Build. We wait a bit. The music is perfect for build results. And the extra gRPC here is, again, so .NET Run. Maybe I should have added a breakpoint. I think I should add a breakpoint. Hang on, something I'm missing. Say hello is this. And I'm doing the, where are you? What are you calling? Say hello. OK. I'm going to do the request here. Where are you? Why are not telling me? .NET Run. OK, found it, finally. Ugh. So you'll notice here somewhere, fail. So we get a fail. Server blah, 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 arrow thrown by something with the internal status code detail not here, try again. And then it continues, and then it gets back with a successful status code. OK, so it's transparent for us. It logs the request, it writes it there. But if you look in the information bit, you'll notice that there is a fail involved. It's a gRPC call exception the first time the things have called. So I'm going to restore this, .NET Run, listens, and then I'm going to rerun this again to see what's going on. So the first time the things happened, blah, 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 not here, try again. It continues. But on the calling party, from my perspective, nothing happened, because the retry is done automatically without me knowing. And if we want to look at that specific the specific code, we should add a breakpoint. Or if you want to try it yourself, add a breakpoint in the server side and see how that retry attempts key gets incremented. OK, some other things, gRPC transcoding, and this is the last bit that I'm going to show you. Well, some people say, hey, I'm not going to use gRPC just because maybe in the future I want to use this as from the browser. And the browsers don't know how to talk gRPC because you cannot have end-to-end a discussion in gRPC from the browser. You'd have to have a tool that you either manage yourself that does the transcoding JSON to byte array gRPC server. So what they did was to invent a package named gRPC transcoding that you have to install. I'm going to try to zoom in a bit. So it's called gRPC JSON transcoding. That allows you to talk gRPC. Also, I show you here the reflection bit. That allows you to discover what you have on a server side, like without importing manually the proto file. So the funny part is here, if you want to add transcoding, you'd have to do some checks and changes. So remember the protocol file where it say hello and stuff? Well, now those get enriched by this bit. Option Google API HTTP. You say, I want to act as a GET request under this specific path for this specific request type. So now when you run the project, I say right-click debug, start new instance. We're going to get a browser instance. Hopefully, Chrome will open today. I'm going to do this, maybe. Then he's going to cry, because why not? Only one instance. Where are you, Chrome? You said you start. Oh, now you're here. OK, so if I take this in the browser, and I paste the endpoint that I added, it's a v1, just to like REST API, name, and then I have a parameter that gets bounded from here. So I add whatever random name, I get it back. But what happens is my request here is actually JSON. If we look on the network tab, say, request method is a GET. Now we get back our status method, HTTP verbs. Content type is application JSON, and it's translated back when we do the request to see the response. So you can also have this flexibility now to say, OK, cool, this is gRPC. It's meant to be used by my downstream APIs. But if in the future I want to expose it in the browser to be consumed by someone else, I can also do that by specifying. You can do post, you can do get, put, and so on. It's a spec that is implemented. OK, so I have to be mindful of the time. What would be the benefits of using gRPC? Well, if you look in terms of performance versus size, good serialization, smaller payload, faster transfer over the network. I did some tests, and I got, in some cases, some 80% smaller payload compared to the same JSON payload. It allows us to have polyglot environments, which we kind of wish we have, but we never have. I don't know, but most of the projects that I've seen have .NET all the way, where they're trying to transition other technologies to .NET API. So this polyglot-y thing is just a thing that it's cool to have, but we do not need it. Because of the payload, we have a low network usage, and it's super nice for point-to-point communication. So if we know where the server is, then we should know it's point-to-point, okay, one-to-one. So it's faster, supports different streaming types that might serve different purposes for different businesses, and it can be configured to run with HTTP 3. As downsides is that you still have that temporal coupling, unlike messaging, where that is not there anymore. And you might forget that there is network involved. You'll need better testing. You'll need to focus more on CI/CD and how you distribute those protocol buffer files. because otherwise you'll end up with copies that are prone to errors and prone to changing. And you have this single point of truth that is the protocol buffer file that you have to distribute and maybe version if in some cases. So distributed systems are all about trade-offs. There is no silver bullet, and we should know our tools, because some are fit for some specific scenarios, some are fit for others. So if you want to look at some other things, you can look at these, HTTP 2, 3, and gRPC web. And also, thanks for listening. And you have the source code here. It will get you to the repository that I have and that you can try it out. So thank you. Enjoy the rest of your conference.